In this video, I'm going to introduce and talk a little bit about the idea of composition of functions. And I'm going to actually start off with some ideas of function notation and comparing the differences between function operations and composition of functions to maybe clear up a few misconceptions and some problems with doing this composition idea. So I'm going to be working with these three functions as we are doing this. Let's hide that. And I'm just going to start with a single function and with this idea of the function mode machine. It's kind of like, what does a function really do? And one way we sometimes talk about functions is we got this machine, and this is my function, say f of x. And what we do with this is we put in some input and we get out some output. The values that we can plug in as our input is what we call the domain. The domain is the list of all of the values that can be the input. So the input comes out of the domain. The output, all of those values we call the range. And the output is going to be a number that's in the range. So in this case, my f of x is this 3x plus 5. So we plug in 3x plus 5 as my function. That's what this box is going to do. But really what happens is I plug in a number, I plug in an x, I get out an output, I get out an answer, I get out an f of x. Now, since this is a line, this is in slope-intercept form, the domain is going to be all real numbers. So anything I can plug in to plug in something from the input, it can be any real number. The output is again going to be any real number. So I could get anything out of it. But I want to come along and let's say I pick up 4 as my input. So I plug 4 into this function f of x, and I'm going to get out inside of this. This is going to think, well, 3 times 4 plus 5 is 12 plus 5. So it's going to output 17, which is part of the range. It is a real number. So let's kind of go and stepping back a step into what are functions, what do they do, what's the way to think about it. Now, when I go to function operations, uh, yeah, let's go over here. Normally, we start thinking about with function operations, our main operations, which are add, subtract, multiply, and divide. When we're doing this, say for addition, if I am taking f of x plus g of x, which I sometimes will write as f plus g of x, you notice I'm going to come back to order of operations. I am doing these things. Now let me just, let's do a segue back to order of operations. You might remember this as, please excuse my dear Aunt Sally. And P was for parentheses. E was for exponents. M and D is for multiply or divide. And we do those kind of in the same level because division is just multiplying by the reciprocal. So we think of them as the same in algebra. AS is again addition or subtraction because subtraction really is adding the opposite. So we like to think we multiply and we add and we ignore these because multiplying and adding is nicer. But once we throw function notation, how does that fall into this order of operations? I'm going to change this from an E to an F. So instead of excuse my dear Aunt Sally, I'm going to forgive my dear Aunt Sally. And F stands for functions. Because exponents really are a function. The exponential function we'll study later, that is just one example of a function. But square roots also fit in here. Function notation fits in here. You think when we look at this f of x plus g of x, before we get to this addition, which is down here, I got to do my functions, which are those two. So that's with all of these operations, add, subtract, multiply, and divide, they all come after evaluating functions. So if we want to say with boxes, say here's f of x, here's g of x. They both have an input. They both have an output. So in this case, if I wanted to do f plus g of 4, 4 is my input, so I would plug 4 into there. My f function is what, 3x plus 5, so I go 3 times 4 plus 5, we already said that's 17. I pull that out down here, 17. G, I plug in 4. My g of x is going to be x squared, so 4 squared plus 3 times 4 plus 2. So what's that going to be? 16 and 12 and 2, 28, 30. 30 is my output. I pull this down here. I first plug my input into F. I plug my input into G. I get those two answers. Then I come down and I add those two answers together. And I would end up with 47. And this is going to be the same with all of these operations. If I'm subtracting, I would first find F, I would find G, and I would subtract those answers. When I'm multiplying, I first find F, I then find G, I multiply those answers. Division, I first find F, I then find G, and then I divide those answers. So in each of those cases, these functions are separate. I come back here, I do the function, then I do these operations. Now, when we get to composition, that changes. So when we look at this idea of composition, think of it almost like an assembly line. And I can't even spell here. So if I wanted to say F composed with G, which equals F of G of X, again, thinking back to order of operations, here when we look at our order of operations, before we do the functions, we got to do what's inside parentheses. Well, here I have a set of parentheses. So before I can do this function f of x, I have to go inside the parentheses, and now here's this function g of x. So I'm going to set up first and do my g of x. And I'm going to have my input here, and I'm going to get my output. But now instead of doing them separately, I take the output from here, and that's going to now become the input for f of x. And then I'll get an output from there. It's kind of like if you're, I think back to when I was in youth groups where we did a fundraiser, we were selling frozen pizzas, where we actually got all the parts of it, and we had to assemble the pizzas. So you'd come along, and first someone would, we would grab the input would be a crust, and then we would put on the sauce, and then we would take the crust and the sauce, and then we would put on the meat, and then we'd go to the next station, and then we would put on the cheese, and so on and so forth. You take what the previous person has done, and you do more to it. Instead of each person does their thing, okay, here I scoop out a bunch of sauce here I put a pile of meat here I put a pile of cheese here. We come and we just kind of throw it all in the bag and make a mess, right? You assemble it, and this composition is more of that assembly idea. So if I wanted to do f of g of 4, which we would write as f composed with g of 4, I have this input of 4, but that input only comes here to my g. And my g of x was that 4 squared plus 3 times 4 plus 2, which we just said was 30. But now 30 becomes the input to my f of x. And my f of x was, I forget already, I've been using it enough, right? 3x plus 4? No, 3x plus 5. So this is going to be 3 times x. Now my x, it's no longer 4, because that was the input to g. It's not the input to f. The input to f is the output from g. 3 times 30 plus 5. So my output is going to be 95. This is a big key to it here. The output of the first function becomes the input of the next function. That gets into that mess with domain and range, which I'm going to talk about on a separate video. So that's kind of the idea working with numbers. Now let's maybe work with a few ideas using the functions to write the function that represents a composition instead of working through it with numbers. But it makes a little bit more sense to start off working with numbers. So with these functions, I want to do this time my f composed with g of x. So I'm doing it for just x, not for a specific point, a specific input. So it's f of g of x. So again, I'm going to start off with g of x. And g of x is x squared plus 3x plus 2. And this is the output. I plug in x. This is the output I get. I can't get that to a number until I know what x is, so I just leave that as that expression. Now, when I do f of x is 3 times x plus 5. But in this case, my x is going to be this whole expression. X squared plus 3x plus 2. So now I go ahead and see what I can do to simplify it. So I distribute 3x squared, 9x, 6, and then we bring down the plus 5, and that's going to give me 3x squared plus 9x plus 11. Now if I switch it around, I do g composed with f. That's g of f of x. Now the first thing we're doing is f of x. So I have to say, well, what is f of x? F of x is my 3x plus 5. And that I'm going to plug into my function g. Again, I first do inside the parentheses, I first do f of x. I can't evaluate it because I don't have x, so I just have that expression. Now g is my x squared plus 3 times my x plus 2. Give myself a little more room here. And my x is 3x plus 5. So everywhere I had x, I put 3x plus 5. And now I can work it out. So my 3x plus 5 squared, remember that is 3x plus 5 times 3x plus 5. And you can use the box, you can use FOIL. If you remember the formula, that's really slick. I'll do it out this way here this time. We can't just distribute the square. Never do that. 3x times 3x is 9x squared. 3x times 5 is 15x. 3x times 5 is 15x. 5 times 5 is 25. So this first one gives me 9x squared plus 30x plus 25. The second one, I take 3 times 3x is 9x. 3 times 5 is 15. And then I have this 2 on the end. So finally I combine my like terms. 9x squared. I got 30 plus 9, so 39x. 25 plus 15 is 40 plus 2 is 42. And this would be g of f of x. As opposed to up here where we had f of g of x was 3x squared plus 9x plus 11. Notice they're different. And usually that's what you expect. Composition is not commutative. It makes a difference which order you're doing it because you're plugging the output of one and using it as the input of another one. If we were doing this as an operation, g times f, it wouldn't matter because we find what g is, we find out what f is, we're plugging the same input into both of them, so we're getting the same numbers, and we're multiplying those numbers together. So that's that idea of composition and kind of how it's different from doing it with those, doing the operations, adding, subtracting, multiplying, and dividing. Because again, coming back to here, let's make this a little smaller so we can get it all in one. When you're doing the operations, you do each function separately and then deal with their outputs. When you're doing the composition, it's an assembly line. You do one function, you plug the input into just one function, you get that output, and you plug that as the input into the next function to finally get your final output.